Right, so we've now got the product rule, and so I've got in the top left here, I've got the structure of the rule and how you present this. I'm going to look into this and then a few questions later on. But just to simplify it, because I know this bit here may look a little bit confusing to some people, so I'm just going to present it in a different form. And I'm just going to look at a very simple example of where we'll say, because we've obviously got, if I just remove that, in the first one here, we've got ux and then vx. And so if I write this, we can say ux, and this is not how you usually do questions, but we'll just have a look into this to help explain it. And then we'll say that vx equals maybe x cubed, for example. So what we're going to do is, obviously, we've got to find f-x, so the derivative. So the product rule allows us to find the derivative where we've got, and let's just say we've got here, using these values, f of x equals 2x times by x squared, for example. And so what it's showing us is that we can actually find the derivative of a function like that simply by following this specific rule. And what it involves, and it may look a little confusing at first, like a lot of these rules, but you'll find that this actual product rule is actually really easy, and you'll find some applications for it later. But what we'll do is, obviously, okay, we've got to find the derivative, so f-x, and so what it says here, we've got two main parts. I think we might digest a little bit. So we've got part 1 and part 2, and so what we've got, we'll say that equals, so the first part we've got u dash, so we know that u is 2x, and we know the derivative of 2x is just 2, so we just got 2 times by, and then just plain vx, so just times by x to the power 3, so that's part 1 done, and then plus, now we've obviously got at the top here, it's got normal ux, so not changing anything there, so just leave it as 2x times y, and we've got v dash, so that will be the derivative of x to the power 3, so it'll be times by 3x squared. And then obviously you could simplify this equation here, but you're not usually going to get scenarios that look specifically like this, and they'll look a little different, and we'll look at this questions like this in a second. But basically the concept behind it is you have your simple equation of two values being multiplied by each other, and you've got two parts for it. The first part where you need to find the derivative of the first part of the function, so ux, multiplied just by the normal second part, that's the value that's being multiplied. And then the second part of it here, you just have the normal first part, so this 2x in this scenario, multiplied by the derivative of the second part here. And then let's just have a look into a few questions. Awesome, so I've kept the rule up in the top left. Now we've got two pretty reasonable, and I'll write a 2 there, two pretty reasonable examples that we can have a look into. So we're going to do this in an evaluated form so we can actually see every single step that we're taking. So with the first example, we've got f of x equals x, and then in brackets x minus 1. So obviously for ux, we've got that, and vx, we've got that. And I reckon what we'll do is we may as well state that. We could say like this equation is the product of u equals x and v equals x minus 1. And then what we'll do is we'll also write the derivatives of these. So we'll say u dash equals 1 and v dash equals 1 as well, because that's the derivative of this function and this function. And then what we can do is we can write the rule. And as I said, I'm going to do this evaluated. So we've got f dash x, we should write therefore f dash x equals u dash v plus u v dash, and then we can say this equals in this scenario, and we can literally simply input these values. So it'll be v dash, we've got 1 times by, oh sorry, it was u dash, and now we've got v times by, and I'll do it in brackets, x minus 1, so it's clear, plus, and we've got normal u, so that's x multiplied by v dash, which is times by 1. And then we can simplify this, and that simply equals x minus 1 plus x, which equals 2x minus 1. So therefore, hang on, this equation here is the derivative of that. Pretty simple. Let's jump over to this next one. So we've obviously now got y equals 4x in brackets 2x plus 1 to the power of 3. So let's do the same process again. We'll write u equals 4x, and I'm actually going to do this a little different, and I'll say u dash equals 4, and you'll see why. We've got v equals 2x plus 1 to the power of 3. And now this is where it gets a little bit interesting, is we can actually use the chain rule in this scenario, because we've obviously got an equation here in brackets with an exponent to the power of 3, and so we can say then this equals 2x plus 1 to the power of 2, hang on, times by, actually we could probably fit that in, can't we? Times by 2 like that. And then we can just evaluate that and just say that equals 6, 2x plus 1 to the power of 2. Hang on, make that look better. 2 like that. And so now this, again, simply allows us to say, therefore, f dash x, and partially for room purposes and actually just so that we can actually present things simpler, I won't show this again because we already know what that is. But if you want to include everything that's great to include, we'll say that equals, so we got u dash 4 times by v, so 2x plus 1 to the power of 3 plus, and we've got u, so 4x times by, and goodness I'm cramming things in, 6 2x plus 1 to the power of 2, which equals 4 2x plus 1, hang on, there's meant to be 1 in there, isn't there? Oh, try and fit that in. To the power of 3 plus, and this will become 24x in brackets 2x plus 1 to the power of 2. So therefore, obviously using this method, this here is the derivative of that using the product rule. Pretty simple, so let's have a look at some more challenging questions. Cool as, so this should be a little bit more interesting. So let's start off with the first one. So we've got obviously this equation here. Let's show the different components. So we've got u equals, and what I'm actually going to do, rather than root x, I'm going to say x 1 over 2, which is equivalent to root x, but we're going to need that a little later maybe. And we've got v, hang on, equals x minus 3 squared, and u dash equals, the derivative of root x is 1 over root x, but so that will be 1 over x to the power of 1 over 2. Oh yeah, and that will actually be 1 over 2x to the power of 1 over 2. I'm forgetting my derivatives here. And then we've got v dash, which simply equals, and actually we're going to need a 2 out the front, x minus 3, and it's to the power of 1, so we can just leave it at that. And actually, I may as well evaluate this to just 2x minus 6, and we'll put that in a little bracket like that. So then let's have a look at the derivative of this equation using the product rule. So therefore, we can find the derivative, so dy over dx. So I'm actually now properly using dy over dx because it's y rather than f dash x like I did earlier. So that equals, and using the product rule, u dash, so 1 over 2, and we'll just say root x to simplify it, times by normal v, which is x minus 3 squared, plus normal u, which is root x, times by v dash, which is, we know is just 2x minus 6. And then we can do some evaluating, so that'll be, and I might just move that to the top, so that'll be x minus 3 squared over 2 root x, and then that'll just be, and we can just do root x, and then the bracket right next to it, 2x minus 6. And then you might think, hang on, could we technically evaluate this and then divide things further and continue evaluating? But what you'll come to find is that is completely useless. If you really want to do it, feel free to waste your time, but all you need to do with the product rule is evaluate as far as we did here, keeping most of the components, but just combining these elements here, just so you get the general idea of what the derivative is. And now jumping over to the next one, we got u equals x squared, really easy. V equals, and this is y, I've got x minus 2, 1 over 2. And you'll now start to see why I presented these without their root form in this scenario here, because this will come in useful. We've got u dash equals 2x, and then I'll do it below v dash equals, and if this was, I kept it as root x minus 2, obviously I could still follow this process that I'm about to do, but it's clearer if I do it like this, because I'm doing the chain rule. Got 1 over 2, because I've multiplied that for the chain rule, x minus 2 to the power of negative 1 over 2, which actually really helps me in working out what that's going to be, which just becomes 1 over 2 root x minus 2, like that. So perfect. And then we can just find the derivative, so dy over dx, which equals u dash, so 2x multiplied by, and this is where I can just write it as the root again, x minus 2 plus, and then we've obviously got normal u, so that's x squared, and then we can multiply that by v dash, which you've managed to work out is 1 over 2 root x minus 2. Excellent. And then we can do our final evaluation like we did before. So just 2x, x minus 2 plus, hang on, we're going to want this on top, aren't we? So it'll be x squared over 2x minus 2. And again, this is as far as we need to evaluate. And you can now see why it is good practice in the step where you're showing what the u and v are, to actually just show it as to the power of 1 over 2 rather than as the root, because scenarios like this, when you need to actually find the chain rule, it is helpful, but obviously once you're putting it into the derivative, it's better to put it back into the root so things are clearer, but you don't have to in some scenarios. Alright, and let's just finish off with one slightly longer question, but still reasonably easy, because that's technically what the product rule is in the majority of cases compared to the other rules. And so I might just underline the question here. So we've got u, which equals, and we know what to do here, 3 plus x to the power of 1 over 2. And then we've got v equals x plus 1, and u dash, and this is where we're going to need to do the product rule again, is going to equal 1 over 2, 3 plus x to the power of negative 1 over 2. Unfortunately, these questions are being very nice to us because we don't need to multiply this by anything, because that x just becomes 1, so that's handy. And then v dash will simply equal 1, which again helps us. So now we've got dy, I can say therefore dy over dx equals u dash, so we can say 1 over root, so this is what this equals, 3 plus x multiplied by v, so x plus 1, plus, now we've got u normal, so root 3 plus x, and then v dash, so times by 1, which really simply evaluates to x plus 1, well actually not evaluates, simplifies technically, over 3 plus, so root 3 plus x, plus, and simply 3 root 3 plus x. Again, really simple process. Don't overcomplicate the product rule. The equation might look a little confusing, and you probably will encounter this quite a lot. It's more just being able to notice that questions like this, you go, okay, this has two main parts that are being multiplied by each other. Okay, cool, I can do the product rule to find this out, rather than following some other kind of process or trying to evaluate this and then find the actual derivative of all the parts that you manage to collect from that. This is really simple process, and it's meant to be like that way. Just practice it a lot and you'll get the hang of it.